students, this question is related to the topic of 2's complement representation of a number from the subject digital logic. This is the question asked in GATE 2010 for CSE branch. First, let us read the question. You can see the question on the board. P is a 16-bit signed integer. The 2's complement representation of P is F8 7B base 16. The 2's complement representation of 8 times P is option A C3 D8 base 16, option B 18 7B base 16, option C F8 78 base 16, option D 98 7B base 16. Okay, in this question he has mentioned P is a 16-bit signed integer. P is a 16-bit signed integer. He has given 2's complement representation of P. 2's complement representation of P is F8 7B base 16. F8 7B base 16. He is asking the 2's complement representation of 8 times P is. See here, one very important thing, 2's complement of a number is different from 2's complement representation of a number. See, 2's complement of a number, if you don't have this representation word, okay, 2's complement of a number means if you are having positive number, if you are applying 2's complement, it will become negative. Similarly, if you are having the negative number, if you apply 2's complement, you will get positive number. Okay, here the wording is very important. Here he has mentioned 2's complement representation of a number. That means if this number is positive, then sign bit will be 0. If the number is negative, sign bit will be 1. That is the meaning of 2's complement representation of a number. Okay. So here you are having P is a 16-bit signed integer. Okay. He has represented that number in 2's complement form as F8 7B base 16. So we have to convert this hexadecimal number into binary. Okay. Right. Just observe this F. This digit F. F is nothing but 4 ones. Right. In that leftmost bit, value is 1. Right. That means sign value is 1. Which is nothing but P is a negative number. P is a negative number. Right. Now, here he is supposed to find out 8 times P. That means whenever we are multiplying a negative number with 8, the equivalent value will be negative. Right. So here he is asking 2's complement representation of 8 times P. That means here the equivalent value is negative. He is asking that equivalent value in 2's complement representation. Here when you do the multiplication of a negative number with 8, the resultant value will be negative, right? So here he is asking 2's complement representation of 8 times P. That means he is asking that equivalent value represented in 2's complement form. That means sign bit will be 1. Suppose if you don't have this one, 2's complement of 8 times P. Okay, that means what? Here you are getting negative number. If you are applying, suppose 2's complement of a number, here it is negative, it will become positive. But in this question, he is asking 2's complement representation of 8 times P. That means sign bit will be 1. So here the wording is very important. Okay, fine. This is the shortcut based question. Okay, first let us try to understand the logic involved for solving this particular question with the help of one example. Okay, later with the shortcut we'll get the answer for this one. Okay, fine. First I am considering a positive number plus 5 base 10. Okay, let us represent this number in 2's complement form with 4 bits. We can represent like this. Here, see, for positive numbers, we are having the same representation in sign magnitude form, 1's complement form and 2's complement form. Here, sign bit is 0, which indicates positive number, right? The remaining bits give the magnitude. 101 is nothing but 5. This is the same representation valid for in sign magnitude form, 1's complement and 2's complement for positive numbers. Okay. Here 0101 is the 2's complement representation of plus 5 in 4 bits. Okay, fine. The same number I want to represent in 8 bits. How I can represent? Plus 5 base 10. Here sign bit is 0. I will put the same sign bit 4 more times to the left side of this number. That means 4 zeros and then 0101. Here sign bit is 0 and remaining bits give the magnitude. The magnitude of this one is same, 5. So plus 5 on. Right? In this way, we can, whatever the sign bit value is there, the same sign bit if we carry n number of times, if we place to the left of that number, the equivalent value doesn't change. Okay. So this is the plus 5. Okay. In 8 bits we have represented. Okay. Now I want to multiply this number with 2. Plus 5 into 2 is plus 10. Okay. Here what I will do, other than MSB, the remaining all the bits, I will do left shift by 1 bit. Okay. Then I will copy here 4 zeros and then 101. Okay. Other than MSB, remaining all the bits I have shifted left by 1 bit. That means LSB is empty here. Okay. Here this LSB I will put 0. Now, what is the equivalent value? Here sign bit is 0. That means positive and remaining bits give the magnitude. 1010 is nothing but 10. Right? So you are getting plus 10. That means if you are doing a binary number, left shift by 1 bit. Okay, after that you are having LSB is empty. There you have to put 0. Which is same as you are multiplying a decimal number with 2. Right? Similarly, let us multiply this number with 2. Plus 10 into 2. That is plus 20. Okay. Here also I will do other than MSB. Remaining all the bits I will do left shift by 1 bit. So here I will get 000, then 1010, and here I am having LSB empty. So I will put 0. Now what is the equivalent value? Here the sign bit is 0. That means positive number. Okay. Remaining bits give the magnitude. 16 plus 4 is 20. Right? Okay. Next. We'll multiply with 2. You will get plus 40. Base 10. Now also, we'll do left shift all these bits other than MSB towards left hand side by 1 bit. So you will get 00, 10, then 100. Okay. Here LSB is empty. You can put 0. Now, what is the equivalent value? 32 plus 8. That is 40. Right? Here sign bit is 0, which indicates positive number. Okay, that means whenever we want to multiply a number with 8, that is same as do the its equivalent binary number, do left shift by 3 times. Okay. So here we got, see, whenever we multiplied with 2, which is same as do the left shift by 1 bit. One more time 2, one more time left shift, one more time 2, one more left shift, like this. So we have analyzed for positive number. Whether the same principle will applicable for negative number or not, let us see. Now I will consider minus 5 base 10. Okay. Here this is the 2's complement representation of plus 5, 0101. Apply 2's complement to this one, you will get negative number. See here, from the right hand side, you have to copy all the bits till you get first time 1. Here in the first bit itself I am having 1. So I will copy this bit as it is. I will complement remaining all the bits. So here you will get 1, then 0, then 1. See here, this is the 1011 is the 2's complement representation of minus 5. Okay. Here minus means negative number. In 2's complement representation, sign bit will be 1. Okay. Similarly here, it is a positive number. Its 2's complement representation is 0101. Here sign bit is 0, which indicates positive. Okay. If you apply 2's complement to this one, you will get this one. This is nothing but negative number. Similarly, if you apply 2's complement to this one, you will get this number. That means you are having negative number. If you are applying 2's complement, you will get positive number. So that's why here the wording is very important. 2's complement representation of a number means you have to, this is the representation. Okay, 2's complement representation of plus 5. This is the 2's complement representation of minus 5. Okay, so wording is very important. 2's complement representation of a number, 2's complement of a number. Okay, right. Now, this is, we have represented in 4-bit. Now let us represent the same number in 8-bit in 2's complement form. So here sign bit is 1. I will place this sign bit 4 more times to the left of that number. The equivalent value doesn't change. See here previously we are having this one. If you apply 2's complement to this one, here this one I will copy as it is, and remaining all the bits I will complement. Remaining all the bits I will do complement. So you will get the same number. So that means in 2's complement representation, if the sign bit is 0, you can place the sign bit n number of times to the left of that number. The equivalent value doesn't change. Similarly, here for negative numbers, if the sign bit will be 1, so you can place the same sign bit n number of times to the left of that number, equivalent value doesn't change. That means the equivalent value of this entire number is same as this number. Because this sign bit 1 I have placed 4 more times, right? Okay. Now, multiply with 2. Minus 5 into 2 is minus 10. Here also we'll do the left shift by 1 bit. Okay. So here you'll get 4 ones, then 0 double 1. Here LSB will be empty. So I will put 0. Now see here. This is the plus 10. Okay, apply 2's complement to this one. From right hand side, I will copy all the bits till I get first time 1. I am getting 1 here. That means I will copy these 2 bits as it is 1, 0. And then I will complement remaining bits. Here 1, 0. 1, 0. Next here 4 ones. Okay, that means what? This is minus 10. 2's complement of plus 10 is nothing but minus 10. Right? Next, multiply with 2. Minus 20 base 10. Okay, do the left shift. Other than MSB, remaining all the bits, do left shift by 1 bit. So here you will get 111, 0, then 11, 0, and here LSB will be empty, so you put 0. Now, apply 2's complement to this one. Here I am having first time 1 I am getting here. So I will copy these 3 bits as it is, 100. Next, I will complement remaining bits. Here you will get 1, 0, 111. That means this is the plus 20. 2's complement of this one is minus 20. Okay, right. Next, into 2. Minus 40. Do the left shift all these bits. Okay, so you will get 11, 0, 1, 1, 0, 0. Here LSB is empty, you put 0. Now just observe whether this is minus 40 or not. Here I am getting first time 1. From right hand side, okay, you have to copy all the bits till you get first time 1. Okay, I am getting 1 here, so 100 I have copied. Next, do the complement of all the bits. 1, 0, 1, 1. 1, 0, 1, 1. That means this is the minus 40. Okay, so whether it is a positive number or negative number, okay, whenever we do the left shift by 1 bit, okay, LSB will be empty, right? So I will fill that bit with 0. Okay, whether it is positive number or negative number. Okay, so whenever we do left shift by 1 bit, it is same as multiplying the equivalent value with 2, right? So that means here if you observe, he has given a number P, okay, in 2's complement representation. Now he is asking the 2's complement representation of 8 times P. That means what? We have to do left shift by 3 bits. Okay, so first I will convert this number into binary. F is nothing but 4 ones. Okay, next 8 is nothing but 100. 8 is nothing but 100. Next 7 is nothing but 0111. Next B is nothing but 1011. Okay, see here if you observe, for each and every time whenever we do the left shift, LSB will be empty, I am placing 0, right? Fine. So here we have to multiply with 8. That means we have to do left shift by 3 times. So whatever may be the 3 bits here I am having, ignore that one. Okay, and here I will put 3 zeros. Okay, now do the grouping of 4 bits. You will get the equivalent value for this one. 2's complement representation of 8 times p. This is the 2's complement representation of 8 times p. Okay, now in the options he has mentioned in the hexadecimal format. That's why I am doing the grouping of 4 bits. Okay, 1000 is nothing but 8. Next 1101 is nothing but D. 0011 is nothing but 3. Next 1100 is nothing but C. C3 D8 base 16. See here, this is the logic. Okay, doing the left shift by 1 bit is nothing but multiplying with 2. Okay, so here the reason behind asking this question is not multiplying 2 numbers in binary. Okay, here whether we know this particular logic, multiplication with 2 is nothing but doing left shift by 1 bit or not. Okay, so if we know this principle, okay, so we don't need to do anything. Just convert this number into binary. Okay, ignore these 3 bits and put 3 zeros here. Okay, since the given options are hexadecimal, do the grouping of 4 bits. Okay, C3 D8 base 16. That means option A is the correct answer. Option A is the correct answer. Okay, in this question, he has given 8 times p. Okay, suppose if it is like p by 8, that means what? Do the division with 2, 3 times. Okay, that means do the right shift by 1 bit. See here, doing the left shift by 1 bit is same as multiplying with 2. Similarly, do the right shift by 1 bit, which is same as dividing with 2. Okay, so here what will happen? Suppose you consider this number. Okay, so we have to do right shift by 1 bit. Okay, that means from MSB to other than LSB, all the bits we have to right shift. So this one I will get 0010 100. So whenever you do the right shift, MSB will be empty. Okay, for positive numbers, I will put that MSB value as 0. Similarly here, for negative numbers, after doing right shift, okay, that means other than LSB, the remaining all the bits I do right shift by 1 bit. Then MSB will be empty. That MSB I will place with this 1. Here sign bit is 1. See here, whenever we do left shift or right shift, the sign bit should not change. Because we are doing what? Suppose here I have considered P is a negative number. Okay, I am multiplying with 8. The resultant value will be negative. Okay, similarly if you are dividing this negative number with 8, you will get the resultant value will be negative, right? So that's why whenever you consider here negative number, suppose after doing right shift, you have to place that MSB value is same as the sign bit, because the sign bit should not change, right? So that's why we have considered. See here, actually for representing plus 5, we require only 4 bits. But why I have represented with 8 bits? Because the reason is, here I wanted to multiply this plus 5 with 8. That is same as what? 3 times I will do left shift. That means in order to take care about this sign bit, okay, that's why I have used 8-bit representation. So in general, whenever he frame the question, he will take care about the sign bit. Suppose if he didn't take care, you have to place that many number of times. Okay, the same sign bit n number of times you can place to the left of that number. The equivalent value will not change. Just like here, if you observe, here sign bit is 0. Okay, the same sign bit I have placed 4 more times. Here sign bit is 1, I have placed 4 more times. Okay, in this way, based upon our requirement, how many number of times we have to do left shift, okay, you can place n number of times the same sign bit to the left of that number. Okay, thank you and keep watching.